Good day, third grade. It's Mr. Tang back again with another, hopefully fun-filled lesson from my third grade mathematicians. The name of our lesson today is Liquid Volume. It's lesson 1 for the week of May 18th through the 25th. Today we are going to solve measurement problems by performing calculations, which is another great example of how we use math as a tool in the real world. And we're going to be using metric units to measure liquid volume, or we might know that as capacity. All right, so before we get started, let's take a look at both of these images and what can you tell that's the same and what can you tell that's different? So I see that they're both containers, that they most likely hold liquid. They both have lines all over them. They both have numbers, maybe some words. Where might you have seen these containers? Maybe the one on the left, you might have seen it in a kitchen, in a cafeteria. What about the one on the right? Graduated cylinder here. Maybe on TV, maybe in science. So think about these containers as we go ahead and move on with our lesson today. Let's turn to our friends at Pearson to learn more about liquid volume and the units that we use to measure liquid volume.
What metric units are used to estimate and measure liquid volume? Let's look at two different units. What is the capacity of the pail? Capacity, liquid volume, is the amount a container can hold measured in liquid units. Two metric units of capacity are milliliters and liters.
So capacity might be a word that you have heard before, and this is really just the measurement of how much liquid a container can hold. In America, we use something called the customary unit of measurement, which you may have seen liquid being measured in gallons, quarts, pints, and cups. This is just another way that we can use capacity to help us understand how much liquid something can hold.
A milliliter is about 20 drops from an eyedropper. This water bottle holds about 1 liter. Step 1. Choose an appropriate unit and estimate. What is similar between the words milliliter and liter?
So liter is the root word here, and we see that in both of these words. The difference here is that we have the prefix milli in milliliters.
They both include the word liter. In the metric system, all units of capacity are related to the liter. What does milliliter mean?
Select your answer.
So if we look at both of our choices here, we have one that says 1,000 liters and one that says 1,000th of a liter. That means 1,000 of these will equal 1 liter. So take a look at our little chart. 1,000 milliliters equals 1 liter. So it's not the other way around. It's not 1,000 liters equal a liter. That would not make any sense.
A milliliter is 1,000th of a liter. A milliliter is too small to measure the capacity of the pail. So use liters. The pail appears to be large enough to hold several liters. Step 2. Check that the estimate makes sense. Count how many times you can fill a liter container and empty it into the pail. To get a valid measurement, the liter container must be filled all the way to the top each time. The pail holds about 8 liters. Would the capacity of the pail change if you changed the unit measure to gallons?
Let's think about this. Would the amount of water that the pail can hold change, or just the way we label it? What do you think?
No, the capacity would stay the same, even though the unit for the capacity would change.
The pail would still hold the same amount of liquid.
Now you know some metric units that are used to estimate and measure liquid volume.
Okay, so next up, we're going to go ahead and take a look at how we can measure liquid volume or capacity.
How do you measure capacity? Let's find out. Eric is cleaning his fishbowl and wants to know how much water he needs to refill the fishbowl. How can he find the capacity of the fishbowl? Eric needs to be precise to measure the capacity of the fishbowl. What does the abbreviation ml mean? The abbreviation ml means milliliters. How many milliliters are represented by each little mark on the 1-liter container? Each mark represents 100 milliliters. If the top mark were labeled in milliliters, what would it say?
So think about this. On this container here, we have two lines represented. The top line says 1 liter. Halfway down, it says 500 milliliters. How many milliliters do you think 1 liter is equal to?
The top line represents 1,000 milliliters. Pour from the fishbowl into the 1-liter container. Empty the container and repeat until the fishbowl is empty. Why is it important to fill the container each time all the way to the 1-liter mark? Unless the container is filled all the way to the 1-liter mark, you cannot accurately measure the capacity of the fishbowl. The 1-liter container was filled 5 times.
As you work, it is helpful to keep a record of the measurements made.
So the capacity of the fishbowl is 5 liters. What other containers might have a capacity of 5 liters? Some containers that might have a 5-liter capacity are a mixing bowl, a large kitchen pot, or a watering can. Now you know how to measure capacity.
We can also think about the liters and milliliters, right? So if we have 5 liters, how many milliliters do we have? If we know that 1 liter is 1,000 milliliters, then 5 liters has to be 5,000 milliliters. Okay, so that was a lot of good information. Let's go ahead and try this out. Question here says, what is the total capacity represented in the picture? So we have liters and we have milliliters. I know that this is 1 whole liter, this is 1 whole liter, and this is 1 whole liter. We don't have a whole liter in this last container, but what we do have is 100 milliliters, 200, 300, 400, 500, 600, 700 milliliters. So altogether, how much total capacity do we have? 3 liters and 700 milliliters. Before we move on to the next one, think to yourself, how many more milliliters do we need to get to 4 liters? How do you know? So if we're at 700, if I add another 100, 200, 300 milliliters, would bring us to another liter. Awesome job. Let's move on. All right, so we have another question similar to the last one with a different image though. So I hope you feel comfortable starting off with our liters. We know that in the first two containers, we have our lines filled to the liter, so we know that we have 2 full liters here, right? We have 2 liters. So let's take a look at our last container then, which is not a whole liter, and we can count by 100 milliliters because each line represents 100. So we have 100 and 200. So we have 200 milliliters. So that means altogether we have 2 liters and 200 milliliters. You can think about this bonus question if you want to. How many more milliliters do we need to get to 3 liters? So right now we have 2 liters and 200 milliliters. How much more milliliters would we need to get to 3 whole liters? You can count on until we get to 1 whole liter in the last container. Let's take a look at a real-world problem where we could apply some of our new learning. Natalie, shout out to Natalie, had a 400 milliliter carton of orange juice and a 450 milliliter carton of apple juice. A friend drank 175 milliliters of the orange juice. How much juice does Natalie have left? So a few weeks ago, we definitely took some time to talk about solving problems that had hidden questions. Here, we're asked to take away 175 milliliters from a total that we don't have. So the very first thing that we need to do is solve for that total. We know we have 400 milliliters of orange juice, and we know we have 450 milliliters of apple juice. So if we combine our ones, we see that we have 0. And if we combine our tens, we see that we have 5. Nothing to regroup there. And then we take a look at adding our hundreds, and we have 850. So we have a total of 850 milliliters of juice. So then the next step that we have to do, now that we have our total, is go ahead and figure out how much juice we have left. So let's go ahead and start with our 850, and we're going to subtract 175. So if we subtract our ones first, we know we can't take 5 away from 0, 1, so we have to go to our tens and regroup. So if we take 1 10 away, we're left with 4 tens, and our 10 can regroup to 10 ones. So now we have 10 ones, so minus 5 ones, we have 5 ones left over. Can we take 7 tens away from 4 tens? No, we cannot, so we have to regroup from our hundreds. We take 100 away from 800, we're left with 700. And if we regroup that 100, we have 10 tens added to our 4 tens. Now we have 14 tens. So 14 minus 7 is 7. Now we're done with our tens. Let's move back to our hundreds place. 7 hundreds minus 100 is 600. So Natalie has 675 milliliters of juice left. Natalie, I hope you're drinking that juice responsibly. Now, boys and girls, that's it for how much work we're going to do together. But for problems like this, go ahead and log onto your Schoology page and complete the Measure Liquid Volume Quick Check in Pearson. Remember that you need to be logged into Pearson to be able to get to your assignment. When you feel comfortable and ready, you can move on to the Show What You Know section in Schoology. A PowerPoint with several practice problems can be found within. You can open up the PowerPoint and use the Draw feature to digitally write on the resource sheet, and then save and upload it for your teacher to see. If you have access, you should also be completing Dreambox lessons, about 6 to 8 lessons per week. Remember that you must first log on to BCPS-1 using your own username and password. Then access Dreambox through the instructional and productivity tools. Boys and girls, you did a wonderful job today, and you have a lot to be proud about. And until next time, stay safe, wash your hands, and do the math.